Next notes we will go over is going to be molecular formula. This is very similar to empirical formula, but it is an extension of it. So oftentimes an empirical formula only shows us the basic ratio of it, but that's not the actual molecule or compound that we have based on the true subscripts. So as you can see from some examples here, we have CH4, as we saw in the empirical video, has no ability to reduce. That was what makes it empirical. But if we were to multiply those subscripts to be times 2, we could get the formula C2H8. It still has the same ratio of elements, and they can be reduced, but technically it's a different substance than CH4. Same thing for the next example, C5H20. That would be if I multiplied these subscripts by 5. Still the same ratio of 1 to 4, but has the ability to be reduced and is a different molecule based on the true subscripts that are present. This example here would not be a molecular formula that has this empirical formula. You can see if I wanted to multiply this by 3, I would get C3H12, not H18. So this molecule actually has an empirical formula of CH6. That would be the common factor in the subscripts that I could reduce to get the empirical. So what we are going to be doing, as you can see from the formula, is really comparing the molecular formula molar mass to the empirical formula molar mass to figure out what the subscripts were multiplied by. Now, when we're doing this, sometimes we're just going to be given the empirical formula already, so we can just plug it in the formula. Or we need to go ahead and go back to the empirical formula video to determine the empirical formula first. And then we can go through and kind of follow the remaining steps. So we'll look at our first example here. In this first example, you can see we are not being given the empirical formula already. And to determine an empirical formula, you always must know the molecular formula and empirical formula molar mass. So without knowing the empirical formula, we can't really answer that question yet. We are given the molar mass of the molecular formula. We can't use it until we know the empirical though. So we're going to do that first. Just like we did in last unit, we are going to convert all of these things into moles and divide by the smallest. And again, pretend that the percents are just our grams. We have carbon, 12.01 for this molar mass. Dividing this, we're going to get 4.537, etc. Hydrogen, 9.1, again, percent becomes grams. Divided by 101, get basically the same number. And then lastly, we have oxygen, which will have a molar mass of 16. Looking to find our smallest here, we would see that it is in fact oxygen. So I'm going to go ahead and divide all of these by this ratio. So here I get 1. For the hydrogen, I get 4. And for the carbon, I get 2. So that makes my empirical formula C2H4O. So that is the very basic thing you need to have to even be able to do these problems. If you don't have it, you have to go through all the work we did in the previous empirical video and catch up to that point. Now, if I go back up to my kind of steps here, now that I've done step 1, I'm going to find the molar mass of the empirical formula. So to find a molar mass, we should know that we're going to take the mass of the periodic table. So for carbon, 12.01, but there's 2 of them, plus the next element, hydrogen. There's 4 of them. And then plus the last element, kind of add everything together times however many there are. There's only 1 oxygen. So that's 16 times 1. Multiplying and adding all of these things together, I get that the molar mass here is 44.06. Okay, so that is an important piece of information that pertains to the empirical formula. Going back up to our thing here, we're going to plug into the formula to determine the multiplier. So we know in pink that the molar mass of the molecular formula is 88, so I put that on top. (88), and then we're going to divide that by the empirical, which we just determined was 44.06. And we're going to get that it is 2. These should always be whole numbers. We should never have a decimal for the comparison here. So if you do, you probably calculated something incorrectly. So this is a multiplier of 2. What does that mean? It means we're going to take all the subscripts in our empirical and multiply them by 2 to get our molecular formula. So C2 multiplies by 2 to become C4. H4 multiplies by 2 to become H8. And O1 multiplies by 2 to become O2. And if you found the molar mass of this, you would find it to be 88. And this is going to be our molecular formula. Once you know your empirical, it's not a whole lot of extra steps. So we'll try one more before I have you try some. So the empirical formula of a compound, CH2, has a molar mass of 70 for the molecular formula. In this case, it already gave us the empirical, CH2. So I don't need to do all of the steps I had to do in the last one where I convert to moles and divide because I already know the empirical formula. So I can skip right to step 2, which is finding the molar mass. C is 12.01. And we know H is 1.01, but there's 2 of them. So if I multiply and kind of add everything together here, I'm going to get 14.03 for my molar mass. Step 3 says I'm going to divide here. So 70 divided by 14.03. And that should give me 5. So that tells me my multiplier. So just like the last problem, the subscript on C in the empirical is 1. I'm going to multiply that by 5. The subscript on H is 2 multiplied by 5. Gives me 10, making my molecular formula here C5H10. In this case, again, if you're given the empirical already, you don't have to go through all the work to find it. You can just plug it in the formula and multiply your subscripts. So going to our next problems here, I'm going to pause the video and let you attempt. I'm going to let you check in kind of halfway through here because a lot of people get a little confused on this one and want to round too much. So firstly, it did not give us both elements percentages. but if we know it's out of 100%, we can figure out what the remaining amount is by subtracting from 100, which would tell us there's 84.1 grams of carbon. Converting to moles and dividing by the smallest is going to give us a subscript of 2.25, which is a little too far away from 2 to round. So we do need to kind of keep it at that fraction, but we can go through and, similar to the other example we had, try to get rid of it. So I'm going to try by doubling it, which will give me C2H5, sorry, C2H4.5. Not quite good enough, so I'm going to double it again. And that'll give me C4H9, which will work. So in this case, I had to double it twice to get rid of a decimal. Now, going from that point, try again to determine what the molecular formula is. Once we figured out our empirical formula is C4H9, we can find the molar mass. 57.13 should be that answer. And then we have our molar mass of the molecular compound, 114.26. When we divide, we get 2, meaning we want to multiply our subscripts on the empirical, 4 by 2 to get 8, and 9 by 2 to get 18, making our molecular formula here C8H18. Okay, try the next problem. In number 2, we needed to find our empirical formula. So going through our process, we would have determined that that empirical formula is NO2. Finding the molar mass of that, we got 46.01. Dividing the molecular 92 by that number, we get a ratio multiplier of 2. N times 2 gives us 2. O2 times 2 gives us 4, making our molecular formula N2O4. Okay, try the next problem. In number 3, they did tell us the empirical formula, which means we just need to find its molar mass, which is 67.12, and then divide. When we divide, we get 8, which means we want to multiply the empirical formula subscripts by 8, making 5 times 8, 40, and 7 times 8, 56, giving us C40H56 as our molecular formula. One more attempted problem here. I'm going to have you pause the video again and try to do this one on your own as well. For the last problem, we were given percentages, but no empirical formula. So again, assuming percentages were grams, we converted that to moles, divided by the smallest to get an empirical formula of CH2O. Finding the molar mass of that, we got 30.03, and then we took our molecular molar mass of 60, divided it by 30, got 2, and then we could multiply our subscripts in the empirical by 2 to give us C2H4O2. And that is how you do molecular formula.